Unit 7, Chapter 14, Arithmetic Sequences. Our goal of this whole unit is to define the words series, sequence, arithmetic, and geometric, to work with those things and prove them, and then of course to use a graphing display calculator to make it easier. 14a and 14b talk about number patterns and general sequences. A sequence is a set of quantities arranged in a definite order, i.e. a list of numbers where there is a pattern, okay, such as 1, 2, 3, 4, 5, 6. The pattern is adding 1. Or -1, 2, -4, 8. Okay, the pattern there is timesing by -2. Or 1, 1, 2, 3, 5, 8, 13. That's actually a famous one. And if you can come to class with that one, you will get an extra credit point. Give me the name of that sequence. Okay, and each number in a sequence is called a term. And they're usually labeled u sub 1, u sub 2, u sub 3. What that means is this is u sub 1, it's the first term. This is u sub 2, it's the second term. Dot, 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 and so on. If you don't know which term it is, some mystery term out there, that's called u sub n. Each u sub n represents a sequence that can be generated by using u sub n for each term. And what I mean by that is u sub n is kind of the general format. It's the formula that will make each term. So for example, this is a formula, u of n equals 2n plus 1, and n is the number of the term that you want. So if we wanted the first term, n would be 1. If you wanted the second term of a sequence, n would be 2. And we're going to go ahead and build this term based off of its general formula, 2n plus 1. So if we wanted the first term, n equals 1, okay, then we want the first term, which we call u sub 1, and so we just plug it in, and it's really just a function, 2 times 1 plus 1, which is 3. If we wanted to know what the second term in the sequence is, that's called u sub 2, so we just plug a 2 into the function. 2 times 2 is 4, plus 1 is 5, so on and so forth. N equals 3. We wanted the third term, 2 times 3 plus 1, 6 plus 1 is 7. And I think that you can see that if we were to list this sequence, so this is the first term, second term, third term, fourth term, dot, 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 and so on. Okay, we could see that the first term is 3, 5, 7. And if you're looking for the pattern, because remember by definition, a sequence is a set of quantities arranged in a different order, or a list of numbers where there is a pattern. If you're looking for the pattern, I hope you can see that they're just adding 10, or not adding 10, excuse me, adding 2 each time. So then without even using the formula, I could see that the next one would be 9, 11, and so on. And the reason the formula is useful is what if I wanted the 100th term? Well, I don't really want to have to add 2 up to the 100th term, so this is the case where I'd want to use the formula. 2 times 100 plus 1, therefore the 100th term must be 201. Okay, and this specific one where we're adding 2 is called an arithmetic sequence. And that is, it's a linear function that grows or that changes by a positive or negative amount from each term. So there are all sorts of sequences, okay? Notice here they added 1 every time. Here we multiplied by 2. That's called geometric. We'll talk about that next time. And this is a famous one where there's a totally different pattern, neither arithmetic or geometric. It's different. But this example here in blue and red is arithmetic, and that's what we're talking about today. So let's define it. For section 14C, an arithmetic sequence is a sequence in which each term differs from the previous term by one fixed number, and it has a specific u of n formula, and that is u of n equals u sub 1 plus n minus 1 d. Okay, and so u sub 1 is the first term in the sequence. D is called the common difference, and that is the number that we're adding and subtracting. It's a number that we add or subtract each time. And n is the number of the term, and n has to be an element of the integers. You couldn't have term 1 1/2. You either have the first number or the second number or the third number. There aren't any numbers that live halfway in between. So n has to be, the first one has to be an integer. Okay. Let's play with an arithmetic sequence. So for example 1, the sequence 2, 9, 16, 23, and 30 is arithmetic. If I want to show that it's arithmetic, that just means show that we're adding or subtracting a number from each term. So just by looking at it, I hope that you could see that the difference is plus 7. Okay, but how you show it is actually showing that this term minus this term equals the same number. So let's see, the second term minus the first term is 7. The third term minus the second term is 7. The fourth term minus the third term is 7. The fifth term minus the fourth term is 7, and so on. Therefore, assuming the pattern continues, and terms differ by 7, then it is arithmetic with u of 1 equaling 2 and d equaling 7. So if in the homework I ask you to show that something is arithmetic, you need to show the differences of as many terms as you can, and then state this sentence. Okay, and this is basically a baby proof. Like I was saying, this is a baby proof for an advanced thing called proof by induction, but this is basically idea. All right, let's find the general formula, i.e., let's find the u of n formula. So we start by writing down this formula. U of n equals u sub 1 plus n minus 1d. And then let's see what we know. We know that our u of 1 is 2. Okay. We don't know what n is because n is just the variable. That's what we plug in for. If we want the fifth term, that's where we put n. Or that's where we put 5 in for n. And d is the common difference, which is 7. Okay, we could see that it was changing by 7. So we put that right there. And we still have, we want u of n because that's the basically the function. And now all we have to do is simplify. So we're going to backwards distribute the 7. And we get u of n equals 2 plus 7n minus 7. And now we're going to combine like terms. U of n equals 7n minus 9. And this is the formula that would make our equation. And actually, negative 7 plus 2 is not 9 now that I look at it. obviously that is negative 5. And if it had been 9, okay, we could have checked it. Let's see, 7 times, if we wanted to know what the second term is, 2. If we had 9 in there, that'd give you 14 minus 9, which is 3. And that is not what the second term is. But if we change it to the right formula, 14 minus 5 is 9, which is the correct answer. So you can always check yourself to see how you're doing. On that note, let's find the 100th term. Okay, so to find the 100th term, that just means we plug 100 in for n. And so our formula is 7 times 100 minus 5, which of course is 700 minus 5, 695. So the 100th term in the sequence is the number 695. Now our question is the number 828 a member of the sequence? So again, if we think about it, the sequence is 2, 9, 16, 23, don't write this down, I'm just showing you something, 30, ... We know that the 100th term, or u of 100, is 695. And the question is, if we kept going, would we eventually run into the number 828? Well, we can figure that out by solving for n, and let me show you what I mean by that. We are going to let u of n equal 828. We're going to assume that it is a member. And remember that u of n is this red formula right here. So we can substitute that in, and we have 7n minus 5 equals 828. And now we're going to solve for n. So add 5 to both sides. 7n equals 833. Divide by 7, and n equals 119. Is it possible to have a 119 term? It sure is. We know that this was the 100th, right? So we could go out 19 more. And if we went out 19 more, our term would be 828. So yes, 828 is a member of the sequence. Let's try one more. Is 2,341 a member of the sequence? So again, we start with let. And you have to say let because we're assuming it is, but we don't know. So we're going to let some number in the sequence equal 2,341. Plug in our formula, so 7n minus 5, that's substitution. Now solve, add 5 to both sides. 7n equals 2,346. Divide by 7. Again, divide by 7, and you get n equals 335 and 1/7, or 335.14. This is not an integer. In this case, n is not an element of z. There is no 335 and 1/7 term, so no, this is not a member of the sequence. Go ahead and try this next question. Before class, it says find the 2015th term. So that would be like example C. Show work. Thank you.